So I've been asked to find the exact value of some functions, and whenever I see this, my brain just kind of immediately says, you know what, I immediately draw these two pictures here, and I've shown these pictures in a few other videos, a 45-45-90 triangle and a 30-60-90 triangle. Now, obviously, if I ask you a 45-degree angle or a 30-degree angle or a 60-degree angle, it's pretty simple to just answer the question from these pictures, but I haven't asked you those today, okay? Instead, what I have asked you is I have asked you angles like 150 degrees, 210 degrees, and so I want to talk about how all of this relates. We have a thing in mathematics called a reference angle, okay? So this guy here we call theta, okay? And we call our reference angle, we call that theta prime, okay? We call our reference angle theta prime. And theta prime is basically when we find something where we can say, you know what, that's the same angle, it's just pointed in a different direction, okay? It's just turned around a little. And so what I want to talk about here for a second is I want to take this angle 150 degrees. Now 150 degrees in standard position, 150 degrees in standard position is going to have its initial leg here and its terminal leg here. And it's going to be, ta-da, 150 degrees, okay? And the terminal leg is in quadrant 2. Terminal leg is in quadrant 2. Now, I like to use right triangle trig definitions. And if you've watched some of my previous videos, my favorite saying is, some old hippie caught another hippie tripping on acid. And so when I look at this, my brain says sine of 150 degrees equals opposite over hypotenuse. Now, I have a problem. These definitions only work in a right triangle. And I come down here and I say, you know what? This 150 degrees, there's no way to make a right triangle out of these two lines in green. Okay? And this is where your reference angle comes in. Is we're going to take and we're going to make a right triangle in quadrant 2. Okay? We're going to make a right triangle in quadrant 2. And this guy here is theta. It's 150 degrees. It's the angle we asked you about. We have to find theta prime. That's our reference angle. That is, how do we get from this terminal side to the nearest x-axis? Okay? And of course, we know this is 150. From here to here is 180. So theta prime must be 30 degrees. And so what I'm here to tell you is the sine of 150 is equal to the sine of 30 degrees in quadrant 2. Now that's important because I can find the sine of 30 degrees pretty easy. Okay, you got your 30, 60, 90 triangle, 30, 60, 90. Here's 30. Sine of 30 is going to be what? Opposite over hypotenuse. Opposite over hypotenuse. Oh, well, that's easy. That's 1/2. But I'm in quadrant 2. Well, look at your right triangle here. Let's make a point. How do I get from the origin to that point? I'm going to go left and up. Left and up. This is going to be negative. This is going to be positive. So this is going to be negative. This is going to be positive. If you use Pythagorean's theorem to find this hypotenuse, you're going to square that number. When you square a negative, it becomes positive. You're going to square that number. That becomes positive, and you're going to take the square root, which is always going to be positive. The hypotenuse is always positive. It's always positive. So negative, positive, positive. So the opposite is positive. The hypotenuse is positive. So what happens? This is positive. Believe it or not, woohoo, 1/2. Okay? Now, there's a quicker way to learn this. There's a mnemonic. All students take calculus. Now, what this means is All trig functions are positive in quadrant 1. Sine is positive in quadrant 2. Tangent is positive in quadrant 3. And cosine is positive in quadrant 4. And I always tell my students, when you're saying this, you need to hold your hand out and say, all students take calculus. All students take calculus. 1, all, 2, sine, 3, tangent, 4, cosine. All students take calculus. I've given tests to students who listen really well and watch them on a test. 1, 2, 3, 4. All students take calculus. Now, don't listen to me. Don't think that I know everything. Let me show you something. Let's take our handy dandy calculator here. Let's take the sine of 30 degrees. That's in quadrant 1, 0.5. The sine of 150, which is 30 degrees from the x-axis, what do we get? 0.5. How about if I said the sine of 210? Where's 210? 210 is in quadrant 3, and it's 30 degrees from that x-axis. The sine of 210, oops, it helps if you type it right. Guess what we get? We get the same number, 0.5, but this time it's negative. Why? Because tangent's positive in quadrant 3, which means cosine and sine are negative. Sine is positive in quadrant 2, which means cosine and tangent are negative. And the last one, 30 degrees from this x-axis, is going to be 330. So the sine of 330, guess what you get? The same 0.5, also negative. So 2 positives, 2 negatives. All of those have a 30-degree reference angle. Okay, so back on track here. Let's do this the shorthand way. Cosine of 210. And I always tell people, you need to realize what is cosine of 210. Cosine of 210 is the exact same as cosine of 30 in quadrant 3. Okay? This is theta. This is theta prime. This is your reference angle. Now, how do I know that? Mentally, I draw this picture. So mentally, I say, look, here's 180. Where's 210? 210's here. Okay, there's 210. 210. How far am I from the nearest x-axis? 30 degrees. That's theta prime. That's theta prime, 30 degrees. Okay, so can I find cosine of 30? Sure, it's right here on this picture. Cosine of 30 is going to be adjacent over hypotenuse, root 3 over 2. Okay, root 3 over 2. Now, that's done. This is the cosine of 30. But I have to do this part. The only thing the quadrant changes is the angle, not the number. Okay? I go back to what I just did with sine. Okay? No matter what quadrant, quadrant 1, quadrant 2, quadrant 3, quadrant 4, same number. 2 of them were positive, 2 of them were negative. The only thing that changes is the sign. So I look at quadrant 3, and in my brain I go, all students take. What does that mean? That means tangent is positive in quadrant 3. The other two are negative. So guess what I'm going to put? Negative. Done. That's how you find the exact value of trig functions. Don't trust me. Trust your calculator. Your calculator is smart. It was programmed by very smart people, but it's only as smart as its user, so you got to know what you're doing here. Let's type the cosine of 210 degrees. Look what we get. Negative 0.866. Now type negative square root of 3 divided by 2. And you got to close your parentheses. And look what we get. The exact same answer. Isn't that cool? I think that's pretty cool. So let's keep going. The tangent of 300. What is the tangent of 300? The tangent of 300, and again, somewhere off to the side, somewhere mentally, somewhere you've got to find where is 300. And you really should know that's 90, that's 180, that's 270. So where's 300? 300's here. 300 is here. 300 degrees. What's that make this angle here? That makes it 60. Guess what that is? That's the closest x-axis. My reference angle is 60. So this is tangent of 60 in quadrant 4. Okay, well what's tangent of 60? Go right to our picture. Here's 60. Tangent is opposite over adjacent. Okay, opposite over adjacent. So what is it? It's root 3 over 1. Root 3 over 1 is just root 3. So I did this part. Now I've got to do this part, quadrant 4. And I say all students take calculus. What does that mean? In quadrant 4, cosine is positive. What does that say for sine and tangent? They're both negative. Okay? So keep moving. And again, can you check this? Can you check this? If you have a calculator handy, you can check this. Tangent of 300 degrees, we get negative 1.732, etc., etc., etc. Now type negative square root of 3. And guess what you get? The same answer. And that's how you know you're right. Kind of cool. All right. Secant. Secant. Oh boy. When I see secant, my classes know to recite certain things. They just, when I say a word, they'll just blurt it out. Okay? When I see secant, I tell people to say flip cosine. Flip cosine. Now what that means is if you can find a value for cosine and you flip it, that's the value for secant. Okay, so I like to say this is flip cosine. Now what's my reference angle? 135. Well, 135 is in quadrant 2 with a reference angle of 45 degrees. Okay, so flip cosine in quadrant 2. Okay, so what I'm really saying is, what's the cosine of 45 in quadrant 2? Okay, what's the cosine of 45 in quadrant 2? Well, what do? I go up here and I take my 45, 45, 90. What's the cosine of 45? It's adjacent over hypotenuse. It's 1 over root 2. So I write that. It's 1 over root 2. That covers this. Then what? In quadrant 2, count all students. Sine is positive in quadrant 2. So cosine is going to be negative. That took care of that. Oops, wrong thing. I circled the wrong thing. That took care of that. Now what? Now I've got to flip it. So flip this. What do you get? You get negative root 2. That's your answer. That's the secant of 135. That's the secant of 135. And if you don't believe me, you can check it. Okay? And you say, wait. I don't have a secant button. Yeah, you do. Let me show you. You have a secant button. You just don't know you have a secant button. So here goes. I'm going to type the square root of, the negative square root of 2. I'm going to hit enter. Negative 1.414. Now, what is secant? Secant is defined as 1 over cosine. So I'm going to say 1 over cosine of 135. That's how you type secant of 135 into your calculator. It's 1 divided by the cosine of whatever the angle is. And what do we get? We get the same answer. That's kind of neat. Last one, and well, not the last one. I'm going to make up one more just for fun. Cosecant of 225. My brain says, look, where is 225? Here's 270. Here's 180, right? Where is 225? 225 is somewhere like this. There's 225. Okay. I can't fit that in a right triangle, so I need to find this angle right here. What is this? What is this angle right here? Okay. Well, how do I find that? Well, 225 minus 180, right? The nearest x-axis is 45 degrees. That's my reference angle. So what is this really? This is equal to flipping And cosecant is a reciprocal of sine, so flipping sine of 45 in quadrant 3. So I find this, put the correct sign, then flip it. That's the answer to the question in green. So I'm going to bring this down here because I've run out of room. I always do that. I box myself into a corner. If you watch my videos, really, really bad about that. So cosecant of 225. Flip sine of 45 in quadrant 3. So I go up here and I say 45. What is sine? Opposite over hypotenuse. 1 over root 2. Oh, okay. So I put 1 over root 2. I took care of that part. Now, in quadrant 3, all students take. That means tangent is positive in quadrant 3. Sine and cosine are negative. Did that part. Now what? Flip it. So if I flip this, what do I get? Negative root 2. That is the cosecant of 225 degrees. And whenever you're asked this, if you have a teacher that asks you a lot of these, give me this exact value, always check them. How do I type cosecant of 225? It's 1 divided by sine of 225. And I hit enter. And look what I get. I get negative 1.414. Okay. And you know, it really helps if you copy your negative, doesn't it? Right? I had the negative here, had the negative here. It helps if I copy that. Negative square root of 2. Same answer. Same answer, folks. Kind of fun. One last question. I'm going to flip the page here. Actually, I'm not going to flip that page. I'm going to go to a clean page. What if I ask you the same question, but I ask you something like the sine of, let me pick a fun one here, 4 pi over 3, or the cosine of, let's say, 11 pi over 6. 11 pi over 6, okay? What if I ask you these exact values? These are the same questions, except, there's a minor difference, except, now instead of degrees, we're in radians. Oh boy. Well, no worries. No worries. Do me a favor. You take your two pictures here, okay? Here's your 30, 60, 90. Okay, 30, 60, 90. And we know that's 1, root 3, and 2. And your 45, 45, 90, right? 45, and I just do that. That's the same angle. I don't have to put another 45 in there. And that's 1, 1, root 2. In a different color, especially if your teacher lets you have a note card and you don't have to memorize this, in a different color, you can tell yourself this is pi over 6. Pi over 6. 45 is pi over 4. And 60 is pi over 3. And if you know these three that I've written in red, you actually can do these easier, or at least as easy as you can in degree mode. Now, what do I mean by that? Well, notice 30 has a denominator of 6, 45 has a denominator of 4, and 60 has a denominator of 3. Because we have to reduce our fractions in mathematics, this is the one time you're going to love reducing fractions. Anytime you see the exact value and it has a denominator of 3, it's going to be a multiple of 60. If it's a multiple of 60, your reference angle is 60 degrees. That's kind of cool. If you see a denominator of 6, it's going to be a multiple of 30 degrees. So your reference angle will be 30 degrees. What do I mean by that? Well, let me draw one other picture just for fun. Okay? We know this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. We know that. But I can come in and add radians. This is 0 radians. This is pi over 2 radians. This is pi radians. This is 3 pi over 2 radians, and this is 2 pi radians. Now, what I mean by that is, let's take for an example 4 pi over 3. Forget the pi for a second. 4/3. 4/3 is bigger than 1. This is 1 pi. Bigger than 1 is going to be somewhere here. Okay? This is 1.5. This is 1.5. 4/3 is greater than 1, but less than 1.5. That means it's somewhere in quadrant 3. Okay? Somewhere in quadrant 3. And because it has a 3 in the denominator, guess what that tells me? This is sine of 60 in quadrant 3. This becomes this problem. Sine of 60 in quadrant 3. Okay, well, what's the sine of 60? 60 is opposite over hypotenuse. Okay, so that's root 3 over 2. And in quadrant 3, all students take tangent is positive in quadrant 3, which means sine and cosine are negative. Go figure. Isn't that cool? And let me just show you. If you say, well, I don't trust you, I need to check it for myself, that's fine. Go to mode. You got to make sure your calculator is in radian mode. Okay? So you scroll down and you put your calculator in radian mode. Now, type negative root 3. Make sure you close that parentheses, divided by 2. You get negative 0.866. Now, do me a favor, type sine of 4 pi over 3. And look what you get. You get the same answer. Now that is cool. One last one just to make sure we've done enough so that everybody's comfortable. 11 pi over 6. What is 11 pi over 6? I look at 11 pi over 6. Okay? 11 pi over 6 is greater than 1.5 and less than 2. Okay? Greater than 1.5 pi, less than 2 pi. So where's it going to be? It's going to be in quadrant 4. It's going to be in quadrant 4. So what is this? This is a quadrant 4 angle. Okay, 11 pi over 6. What's in the denominator? A 6. Guess what this is? This is cosine of 30 in quadrant 4. Well, what's cosine of 30? Cosine of 30 is adjacent over hypotenuse. It's root 3 over 2. Root 3 over 2. And in quadrant 4, all students take calculus. Cosine is positive, so guess what? I put a positive in front of that just to make sure that I know I've done this part. Did that, got it. You can check it on your calculator. I hope that helps you understand reference angles and how all of this works. Really sit down with a calculator, type in cosine of 30, cosine of 150, cosine of 210. See what you get. See how this works. See that it actually works. It's not some BS that someone's throwing at you. And you can actually learn a lot. And if you really understand this stuff, you can use it for so many things. It's really cool stuff. Okay? If you have any questions, please let me know.